Hello guys, today I'm going to see about the basics of electrical. So if you are from a background of electrical engineer, first of all you need to know what is meant by electrical and electronics. Okay, so you know that there are two charges available. One is positive and negative. So in electronics, we deal with both positive and negative charges where we apply these two charges to one system and analyze how the system react to it. Okay, but in electrical, where we deal with only one charges, that is negative charges, where we apply these charges, this charge to a system and analyze how the system react to this charge. In electrical, we use above 240 voltage, but in electronics we use voltage that below 50 volt. It is a main difference that you need to be known in terms of electrical and electronics. So in electrical, there will be three important parameters, that is current, voltage, and resistance. First of all, current means the flow of free electrons in a metal is known as electrical current. Or you can say that the electrons without orbit in a metal is known as electrical current also. So it is to measure in terms of ampere, and also it is denoted in terms of capital I. So let us use an example. Let's take a copper bar. In the copper bar, there will be a free electrons will be wandered in all direction. If we apply a voltage to it, the free electrons attain and start to move towards the positive terminal. This phenomenon is called as electrical current. And the formula to measure electrical current is dq by dt, whereas the q refers to charge. And then next is voltage. This is one of the most important concept in the placement perspective and the basics of an electrical terms. So we in the last section we see that what is the current. Here it is a work done in moving the electric electron from one poles to or one place to another place through the metal or a wire. That is known as voltage. Okay, or it can be said in simple term, a pushing force that pushes the electrons. Okay, in another term also can explain a capacity of charge body to do some work is known as voltage or electrical potential. For example, let's take a battery. While we're charging the battery, there will be some work done on it. If the battery is connected to a load, the battery start supplying voltage to the load. This phenomenon is called as voltage or electrical potential. Okay, the formula for voltage is V is equal to work done by charge, where it denotes in the volt. And there is another term is called potential difference. It means the difference in the potential of two charge bodies is called as potential difference. So once again, I will tell that the difference in the potential of two charge bodies is known as potential difference. For example, a point A consists of 50 volt, a point B consists of 30 volt. Then now the two charge bodies have a 20 voltage difference, 20 volt difference. This is called as potential difference. These concepts we see in batteries, the positive negative terminal. Resistance. So resistance refers to a substance that opposes the flow of current. Okay. For example, my body has some resistance. In this world, each and every material has some resistance. My body has some resistance. If I go and touch a 12 volt battery, I will not feel any shock. If I go and touch a transient line, I feel shocked. Why? Because the flow of current is greater than my body's resistance. That's why I get shock. This is one of the example for resistance. It is to measure in terms of ohms, and also it is represented in terms of R. And there are some laws for resistance. First law is resistance is directly proportional to length. If the length is increased, the resistance also will be increased. That's one of the reason why most of the transmission does not use copper. Why? Because copper has more resistance value. For that, they use aluminum because aluminum has less resistance value. And resistance is inversely proportional to the cross sectional area of the conductor. Okay, and resistance will be depends upon the nature of material. I already said that in this world, each and everything has some resistance value. Like I'm a body, my body has some resistance value. The glass tumbler has resistance value. Material still have some resistance value. So each and material will be differ each other, and the resistance will be depends upon the temperature also. And one of the most important laws or basic law, that is Ohm's law. Okay, so we know that the basic definition, at a constant temperature, the current flow through a circuit is directly proportional to the potential across the circuit. Okay, so first of all, we see the example, then you can easily understand the concept. Let us take this circuit, wherein the circuit is closed circuit. When we apply a voltage, there will be a flow of electron will happen. So now the flow of current will depends upon two factors, that is the resistance of circuit and also the applied voltage. So by using these three concepts, George Simon Ohms defined this Ohm's law. Okay, that's why it is called as V is equal to I into R. Whereas the I R refers will be constant. Why? Because I already said that in each and every material has some resistance value. Likewise, each and every circuit also has inbuilt resistance value. That inbuilt resistance value oppose the flow of current. That is one reason that by using these three relationships, current, resistance, and applied voltage, by using these concepts, George Simon defines Ohm's law. So there will be some limitation for the Ohm's law also. First of all, it is not applicable for unilateral network, and it is not applicable for non-linear device such as xenodiode and then voltage regulator and all. And it is not applicable for non-metallic conductors. Non-metallic conductor refers to like papers, glasses, plastics. Okay, so and it is not applicable for complicated circuit. Yeah, we can use Ohm's law, but calculate is more longer. It is a lengthy process to calculate and use solution for that. For that, we use different theorems like superposition theorem, Norton's theorem, Maxim Porter theorem. For a complex circuit, we use theorems and all. For simple and basic for easy solving, we use Ohm's law. And then next is electrical power. So electrical power refers to the rate at which work done in electrical circuit. So for example, I can example. Let's take this circuit. When we apply the voltage in a closed circuit, there will be a flow of electric current in the circuit. Now, when you apply voltage, there will be some work done to move the electrons. So now the work done is measured in terms of with respect to time, is known as electrical power. That's why power. So its SI unit is watt. So the formula for electric power is P is equal to V into I, or we can also express in terms of P I square R, and also P is equal to V square by R. There will be three formulas. It also measured in terms of watts. The last but not least, that is electrical energy. In the last section, it sees that electrical power. The electrical power which has been multiplied with respect to time is known as electrical energy, or the total work done in